Hello everyone, today I am going to show you how we can implement Spring Batch into our Spring Boot application. So here we will use Reader, Writer, Processor. So with the help of Reader, we will read all the data from S3 bucket. Suppose in S3 bucket, we have a multiple files, and if we want to read all the data from all the files, then we will use Reader. Okay. Then we have a processor. So with the help of processor, we can modify or transform our data. And then we have a writer. So with the help of writer, we will write all those data inside MySQL database. And we will use listener. So with the help of listener, we can perform any type of action before or after the job. And at the end, we will create a manual endpoint. So with the help of that endpoint, we will trigger our job. So let's start.
And this is our AWS dashboard. Here we will search S3 and then we will have to choose this buckets option and we will be redirected here. Then click on this create bucket button and then write the bucket name. You can write any name. And then scroll down and click on this create bucket button. Then one bucket will be created. So this is our bucket. If you go here inside this bucket, then you will see no files are there. So I am going to upload one file. I am going to show you that file. Okay, so this is our file userdetail.csv. so this file we will read from Spring Boot. Okay, so this is our file and here you can see there are 3 columns: role, name, email. So we will read these all columns from S3 bucket and around 1 lakhs of data available inside this CSV file. So firstly I am going to upload this userdetail.csv file over S3. So click on upload and then click on this add file button and then choose that file. Okay, so this is our file and click. Now we will have to upload this, so click on this upload button. So our file has been uploaded successfully over S3. Close this. Then you can see this is our file and click on this buckets option. Then you will see all the list of buckets. So I am going to click on this bucket and you will also see this is our file. Okay, now our next step is to create a Spring Boot application, but before that I am going to open phpMyAdmin. So just write localhost/phpMyAdmin. So this is the phpMyAdmin dashboard. And now I'll create one Spring Boot application. So write Spring Initializer on new tab and then hit enter and click on this first option. Then you will be redirected here in Spring Initializer dashboard. Here we will have to select language, project, version, and we have to provide some basic informations like group, artifact, project name, and we have to select jar and Java version. Okay, so these things we have to provide here. Now we will have to add some dependencies. So first dependency I am going to use as Spring Web for RESTful APIs. Okay, and the second dependency I'll select Spring Data JPA for persist data in SQL. Okay, and the third dependency I am going to use Spring Boot DevTools for hot reloading. So that's why I am using this Spring Boot DevTools. And the fourth dependency I am going to take Spring Batch. Okay, because we are going to use Spring Batch into our Spring Boot application. And the fifth dependency I am going to take MySQL driver for MySQL connectivity. So and then click on this generate button. So the project will be created inside our download directory. So first I am going to open download, and this is our project. So I am going to extract this. So right click on this project and then click on extract all and then extract. So this is our project, and go inside here, then these all files are here. Okay, so this is our project. Cut this project from here, and then I'm going to place this file on some other directory. You can place on any of the directory into your system. So this is our project, and these are all files. Now I'm going to open this project from IntelliJ. So click on this open and then select our project. So this is our project. I'm going to select this project. Okay, this is our project. So click on OK button. So our project is loading now. Just expand src main java, and then I'm going to remove these unnecessary spaces here. This is not required. Okay, and in a pom.xml file I'm going to show you all the dependencies which we are going to use. So this is the batch dependency, this is data jpa, and this is starter web, and then we are also using devtools, and we are also using MySQL connector. So now I am going to open notepad. So I have this dependency, so we will have to add this dependency for s3 connectivity. Okay, so just I'm going to copy this. You will have to use this dependency. Okay, if you are using s3 bucket. So just add this dependency into your pom.xml file inside these dependencies. Okay, and now we have to install this dependency. So I am going to click on this Maven and then go inside this lab cycle, and then I will try to clean this project and then install this project. I think it will fail. Okay, so to properly install all the dependencies, here you can see in message error creating bean with name data source. Okay, because the configuration is not there inside our application.properties file. So I am going to collapse this and then open this application.properties file, and then I am going to rename this with YML, because YML support hierarchical architecture. So I am going to use as application.yml file, and this is the application.properties configuration. So I am going to copy the project name, application name, and just remove this and write spring application and name, and then provide our application name. So this is the hierarchical architecture that we are using. After this we will use data source, and we have to provide URL here. So just provide URL, then we will write JDBC here, and then colon, and we will use MySQL because we are using MySQL, and after that we will have to provide localhost. If you are using live server, then you can provide IP address and all. And in MySQL you can see this is running on 3306 port, so I am just going to provide this port number here, and after this we will have to provide database name. So I am going to create one database. So click on new and then write your database name. Okay, and then click on create button. So now one database created, and in IntelliJ just write the database that you have created, and then I'm going to provide username, and the by default username of MySQL jam server is root, so I'm providing this as root, and password is blank, so I'm not doing anything in password. Okay, you can provide your username and password here of your database. And after that we will use JPA and then write hibernate here, and here we will use DDL auto update. Why we are using update? Because suppose one table is already created inside database, then on the next time I don't want to create new table, we want to update that table, so that's why I'm going to use as update. Okay, and here we will use show SQL true, because we want to show all the queries in logs, so that's why I'm using show SQL as true. And then we will use batch here, and we will provide batch configuration, so write batch, and batch in batch configuration we will have to provide two things, JDBC and job. In JDBC we will have to provide initialize schema always, so when the application will run, then it will automatically create all the tables related to batches, so that's why we are using initialize schema always here. Okay, and then we have to write job here, and we have to provide the information whether the job is enabled or not. So if we write true, then we don't need any type of endpoint, it will automatically execute our batches. Okay, but I am providing false because we will create a manual endpoint to trigger our job, so that's why I am providing false here. And we will also add S3 configuration, so write S3, and then we will use access key, secret key, and we will have to provide bucket information, bucket name information. Okay, so I'm not going to write access key and secret key here because these are credentials, and bucket name we will get from AWS dashboard. So this is our bucket name. Okay, so copy this bucket name, and then paste here. I will provide this access key and secret key later. Okay, so our configuration code is completed. Now I am going to I'll create one package, and that package would be the type of model. So here we will create our model class, so user model, and then we have to provide some variables, but before that we will have to annotate with @entity because we are going to create a table. So write entity, and then we have to use table and then provide the name of the table. So I am going to mention my table name as users, and inside this class we have to provide some variables. So if you go here inside this file, then we have three columns, role, name, email. So we have to create these all columns variables inside user model class. Firstly I am going to write ID. Okay, so this will be the type of long, and this will be primary key, and this will be auto increment, so I am going to use as generative value and then write strategy equals to generative value dot identity. Okay, so this id will behave as a primary key. And after this we will create some more variables like role, name, email. So write private string role, the first column is role. Okay, and the second column is name and the third one is email. Now we have to create getter and setter of all the fields. Okay, so just select all the variables and then press alt insert and then select all variables and create getter and setter. I'm going to cut this from here to organize and then paste above this. Okay, so paste these all variables here inside this user model class. And then now our next step is to create one more package. So we will create one more package for listener, and inside this we will have to create one Java class that would be user listener. Okay, and we will assign this listener as @component. So annotate with @component, and then we will have to implement with job execution listener. And as you know that job execution listener provides two method. So we will have to override two method, before job and after job method. So override first method public void and then write before job, and then here we have to pass job execution. Okay, so this is our first method which will execute before job, and again we will create one more method for after job, so this will execute after the job. Okay, so we have to override these two methods which we will get from job execution listener. And inside before job I am going to show one log before the job, so just write system out println and then I am going to show the job name before the job. Okay, that we are going to trigger. And we will get the job name from this execution, so write execution dot get instance get job instance dot get job name. Okay, so from this we will get the job name. Similarly I am going to copy this log from here and paste inside this after job method, and here we will show job status after job completion. So write job status here and just remove this job name and write get status. So we will get the status of the job with this way. So we have successfully created our listener. Now I am going to close this. Again I am going to create one more package, and this will be the processor. So inside this we will have to create one more Java class that would be user processor, and user processor basically it will use for modify the data. Okay, so we have to annotate with @component here, and we will have to implement with item processor, and it will take two parameter. The first parameter would be user model and the second parameter would also be user model. And then we have to override one method here to resolve this issue. So click on this implement method, then we have to override this process method. Click on OK button, then you will be able to see this method, and then change this item to user we can modify our any data here. Okay, if you want to modify your name, email, role, then we can directly modify here. So that's why we are using this user processor here, and then pass this user in return. Now I am going to close this, and our next step is to create writer package, and then create one Java class of this writer, and the name would be user writer. And here okay, so firstly I am going to annotate with @component here, and inside this we will take one bean. Okay, and write public void. We will use JPA item writer here. Okay, and the type of JPA item writer would be user model. And here we will initialize and declare this JPA item writer. And this function return type is JPA item writer. Okay, so we'll have to provide a writer on return. And now we will have to pass entity manager factory here. Okay, so this will automatically save the data into the database. We will have to inject this entity manager factory here, and then we will use writer dot set entity manager factory, and we will have to pass this entity manager factory so that the data will be automatically inserted into the database on the basis of chunk. Now we have to return this writer, because we have to return this writer. Okay, because the return type is writer, so we'll have to return the writer. Now I'm going to close this writer, and the next step is to create one more package, that would be config. So we will create a pipeline of reader, processor, writer. Okay, so just create a Java class that would be okay. Firstly I am going to create one S3 configuration class. Okay, so this will be the configuration class, so annotate with @configuration, and then just create one bean. And here you can see we have multiple credentials like access key, secret key, bucket, so we will use those things here. And this is inside Spring S3, and then access key, secret key, and bucket. So write all the variables here like private, string, and then we will write access key, and this access key we will get from application.yml file. Similarly I'll create one more variable for secret key. Okay, and we will get these all data from here. So write @value, and inside this value write dollar, and then we have to provide the location. The location is spring.s3.access key. Okay, so I'm going to copy this access key and paste here. So copy this value again, and here I'm going to paste this again, and copy this secret key and then paste here. So these are our access key and secret key. Now we will have to create one bean of S3 client. So write @bean, and then write public, and then write S3 client. Okay, S3 client is not accessible, so I think we need to load all the dependencies correctly. Okay, then it will work. So click on this M, and then just compile this. If this will not work, then we'll have to remove all the caches and click on invalidate cache, so it will work. Okay, Now I want to try. Okay, so write @bean and then public and then write s3 client. Still it is not accessible, so we will have to perfectly install all the dependency, then it will work. Okay, so I am going to click on this invalidate cache and then clear all the caches and restart our IntelliJ. So I think it will work. Okay, so wait until all the dependencies perfectly installed. So now you can see all dependencies installed successfully. So now I'll try. So write @bean and then write public and then s3 client. So here you can see s3 client is accessible. Okay, and then write s3 client object and then inside this we will have to use AWS basic credentials and write AWS basic credentials and then we will write AWS creds equals to AWS basic credentials dot create, and here we need to pass two things, access key and secret key. So just pass both here and then we need to return our s3 client. So write return and then s3 client dot builder, and now we have to provide region. Okay, so we will get this region from our AWS dashboard. So write region dot, and I am using AP South 1. Okay, so I'm going to show you where you can see this region. So open this AWS dashboard and click on this option, and this is the selected region which I am using, AP South 1. Okay, so you can use your own region. If you go here inside this, then you will get all the region details. So I am using AP South 1. So click this, copy this key, and then I am going to close this file, and here you can see same key I am using. Okay, just copy this key, close this file and then paste here. So same region here I am using, and after that we have to provide our credentials provider which we have already created, and then write static credential provider and pass our credential, AWS credential. Okay, this credential we have to provide, and then write dot build. Okay, so this is our s3 configuration class. And now I'm going to create one more package that would be a reader. Okay, so with the help of reader we will read all the data from s3. So just create a reader Java class. So write user reader, and then we will annotate with @component. and inside this reader we will have to read the data. So just I am going to take one bean, and here we will use multi-resource item reader, because we will have to fetch all the data from multiple files which is available on S3 bucket. So that's why we are using multi-resource item reader, and this will be the type of user model. Okay, so pass our model here, this model, and then write reader, and inside this we will have to initialize, no, firstly I'll take one array list. Okay, so firstly we will use one list, and this will be the type of resources. Here we will store all the streams which will come from S3 bucket. Okay, so just import this list, and then a new array list. And now we will have to fetch all the files which is available on S3 bucket. So just write, so create a request to get all the files which is available on S3 bucket. So we will use list object v2 request. Okay, and then we will write dot builder, and after that we'll have to provide bucket. So here we need to pass our bucket name. So to get the bucket name, here you can see in application.yml file, this is our bucket, and this is inside spring s3 and then bucket. So we will have to provide the location here. So create one variable bracket, create one variable that is private string bucket, and then we will have to use @value to access the value which is written inside application.yml file. So write spring dot s3 dot bucket. Okay, so this is the location of bucket, and then pass that bucket here, and then write if you want to add any type of prefix, suppose your file is user details, and if you want to add any prefix like user, any suppose many files are there, and if you want to fetch only specific files which is starting from user, then you can provide here prefix. Okay, but I'm not going to use any type of prefix here. Okay, so write dot build here, and then now we will use this request. So we will use for loop to fetch all the files, and we will pass this request there. Actually I did mistake. Okay, so we will have to use list object v2 request here on both places. Okay, and then I'm going to create one for loop. So here we will use s3 object, and then write obj, and then we will use s3 client. So we will have to inject this s3 client here. So write @autowired, and then we will use private, and then write s3 client. So this is the configuration class. So write s3 client, here you can see inside bin we have this s3 client, so we will have to use this s3 client. So write private s3 client, and then we have to provide this s3 client here dot list object v2 we have to pass here, and then we need to pass our request that we have already created to get the data from s3 bucket. So pass this request here, and then in the comma, and then write dot contents to get all the list of the files. and here we will check the file extension. So write object.keys.start with end with, if this will end with .csv, then we will only read from S3 bucket. Okay, so you can write, you can implement any type of condition here. So object.key is the file name. Okay, and here we will use input stream. If the file extension is .csv, then we are only fetching those files, so that's why we are using input stream here. And then write s3 client.get object, and here we will have to pass our file name. Okay, sorry, we will have to pass our request. So just write get object request dot builder, and after builder we will have to provide our bucket name. Okay, and now we have to provide our file name. Key is the file name, so this is the file name object.key. So just pass this object.key, and this will be the file name, and after this we will have to write .build. Okay, so with this way we will get all the files whose having extension is .csv, and we will add all the streams inside resource list. So just pass this stream here. Okay, inside resource list we are adding all the streams, all the files, and after this for loop we will use FlatFileItemReader. So use FlatFileItemReader. Firstly we will initialize and declare FlatFileItemReader, and this will be the type of user model. So I am going to take object name as delegate, and then write new FlatFileItemReader, and then here we will use delegate.skip lines, set lines to skip. So we will skip first line, because in the first row we have our name, email and role, so we are just going to skipping first row. Okay, so that's why we are just skipping first line. Okay, here you can see role, name, email. So this is our first row. We are not going to read with the help of FlatFileItemReader, so we are skipping this line. And now after this we have to use default line mapper. Okay, so in default line mapper, basically line mapper takes two things, tokenizer and field set mapper. So firstly I am creating this delimited tokenizer, and then I am going to provide delimiter as comma. So we will separate all the data on the basis of comma, which we are reading from S3 bucket. Okay, so this is our tokenizer, and here we have to pass tokenizer dot set names. So we have to provide all the columns names like role, name, email. So we will tokenize all the columns. Okay, on the basis of delimited tokenizer, and we are separating on the basis of comma, role, name and email. So these are the column names, and after this we will have to use bean wrapper field set mapper. Okay, so with the help of this we will have to map all the tokenized value on the basis of user model. Okay, so just initialize and declare this bean wrapper field set mapper here, and in the mapper we will have to pass target type. So in the target type we will have to use this model, user model. Okay, so these tokenized value will map according to this user model variables. So that's why we are using this bean wrapper field set mapper. And after this we will use default line mapper. So we will have to initialize and declare that default line mapper. Okay, and we have to pass this tokenizer and field set mapper inside default line mapper. So now write line mapper dot set of line tokenizer and then pass our tokenizer here, this tokenizer. Okay, similarly I am going to use line mapper dot set field set mapper and then pass our mapper here. And now we have to so this is our reader and the reader name is delegate. Now we will set this line mapper inside our delegate. So delegate dot set line mapper and then pass our line mapper here. And as we know that we are reading the data from multiple files which is available on S3 bucket, so we will use multi-resource item reader. And okay, and we will also have to return this multi-resource item reader, so we will use this multi-resource item reader. Okay, so just write this and then this will be the type of user model. So just initialize and declare this multi-resource item reader here. And with the help of this multi-resource item reader, firstly we will have to set resources, and the resources we have this list, resource list, and in this resource list we are just passing all the streams which we are getting from S3 bucket. So just pass our resource list here, and this will be the type of to array, and then write new resource and in the array pass 0. And after this line we will have to provide our delegate inside this multi-resource item reader. So just write multi-resource item reader dot set delegate and then pass our delegate which we have already created, this delegate. Okay, and as you know that return type is multi-resource item reader, so just pass this multi-resource item reader here, return this. So our reader code is also completed now. So firstly we declare S3 client and bucket name, and then we have created a one bean that is the type of multi-resource item reader. Then we have created a list, resource list. Here we are just adding all the streams which we are getting from S3 bucket. And then we have created one list request. Okay, so on the basis of that request we are fetching all the files from S3 bucket. Okay, and we are checking the condition. If the files extensions are .csv, then only we are reading the files from S3 bucket. And then we are using this input stream to get the files, and we are passing our bucket and file name. Okay, and we are adding all the streams inside resource list. Inside resource list we are adding all the streams. Okay, and after this for loop we are using this flat file item reader, and we are skipping the first row. In the first row we have name, role, email, and after this we are using this tokenizer to separate all the columns on the basis of comma, and these are the header names, role name, email. And then we are using this bean wrapper field set mapper to map all the tokenized columns like role, name, email. And then we are using this default line mapper, and as we know that in default line mapper we can pass tokenizer and mapper. So we are just passing this tokenizer and mapper here, and this is the delegate. So inside delegate we will have to pass line mapper, so that's why we are using this delegate here. And we are reading multiple files from S3 bucket, so that's why we are using this multi-resource item reader, and we are passing our delegate here, and we are also passing our resource list. Okay, and we are returning our multi-resource item reader. Okay, this delegate, and we are returning this. So our reader code is also completed. And now I am going to create one more config class, that would be batch config. Here I'll create a pipeline of reader, processor, writer, so those will work in a sequence. Okay, a reader, processor, writer, for these all we will create a pipeline here. So this will be the type of configuration. Okay, so just annotate with @configuration here, and inside this class we will have to use two things. First one is the job repository, and the second one is the platform transaction manager. So job repository basically used to manage steps and jobs, and platform transaction manager basically used for commits and rollbacks. Okay, this will manage steps and jobs. And the second one I am going to inject platform transaction manager. This will be transaction manager, and after this we will have to create two beans. The first bean would be step. Okay, so write public step, and just import this step from batch core library. Okay, and this step name would be user step, and inside this we have to pass three things: reader, processor, writer. Okay, so reader we are using this multi-resource item reader. So I am going to copy this and then paste here. Okay, so this is our reader. Similarly I am going to use processor. So this is our processor, so we will use user processor here, and then we will use user writer. So copy this. Okay, JdbcItemWriter, and then paste here. Okay, so these three things we are going to use inside this user step, and then we will have to return a step builder. So write return new step builder, and step builder will take two parameters. So the first parameter is the user step name, and the second parameter would be the job repository. So write the name of the user step, and the second parameter would be job repository. So just pass this job repository here, and after this we will have to provide chunk. So write dot, and in the angle bracket we will have to pass our user model two times, and here we need to write chunk and then write new simple completion policy, and inside this we will have to provide our chunk size. Suppose if you want to keep like 1000 chunk size, 2000 chunk size, then we can pass here. Okay, so I'm going to use as 1000, and after this we will have to use transaction manager, which will manage rollback and rollbacks and commits. So I'm going to pass this transaction manager here. Okay, and now hit enter. Then we will write dot, and then we will have to pass reader, processor, writer. So firstly I am going to pass our reader. So write reader and then pass this reader here. Similarly, I'll pass this processor. So write processor here, and again I am going to write writer and then pass this writer, and at the last we will write dot build. So this is our user step bin. Okay, so similarly I am going to create one more bin that would be the type of job. So create one more bin. Okay, and we are creating a pipeline of reader, processor, writer, so this will execute in a sequence. Okay, so that's why we are using this reader, processor, writer here. Now I am going to create one more bin for job. So write public job and import this job from batch core libraries, and then write user job. This will be the name of our job, and here we need to pass two parameters. First one is the user step, and the second one would be the listener. And in listener you can see we have two methods, before job and after job, so that will execute. So firstly I am going to use step, and the step name is user step, so just pass this same user step name, and then we will have to use this listener. So write user listener, and this will be the listener. And now we will have to return this job. So write return new, and then write job builder, and job builder will take two parameters. First one is the name, and the second one is the job repository. So pass the name of the job that we will execute from our controller when we will create manual endpoint. Okay, and the second parameter we have to pass this job repository, same job repository here. Okay, and now we will have to use incrementer, and then write new run incrementer. So this will create a unique ID on every instance. Okay, so that's why we are using this incrementer here. And after this incrementer we will use listener. So write dot listener, and then pass this listener. Okay, and here we will use dot start and then pass our user step, so the pipeline will be executed. And then write dot build. So we have successfully created our batch config class, and we have created our pipelines, and we have also created our two bins, one for the user step and one for the user job. Okay, now I'm going to close this. And now I'll create one more package for controller. Okay, so now I'll create one manual endpoint to trigger our job. So create one Java class that would be user controller, and then here we have to annotate with @rest controller, and then we will create one more, add one more annotation that would be rest request mapping, and here we have to provide one endpoint that would be batch. This is not required. Okay, and now we will use two things here inside our controller. First one is the job launcher, and the second one is the job name. So with the help of job launcher we will execute our job, and with the help of job we will get the job name. So just inject both of the things here. So write private job launcher and then job launcher. So next one is the job. So inject our job here @autowire, and then write private, then import job from this batch core library, and then we will have to provide the job name, which we have already defined into our batch config class. So copy this user job from here and then paste here. And then now we will have to create one manual endpoint. So I am going to use one method that would be the type of get, and then pass one endpoint, start job, you can take any name, okay, and then write public, and I'll create one method that would be the type of string, because we will return the job status, whether the job is completed or failed, and then write the function name here. And here we will create a request of our job. So firstly we will create job parameters, and then new job parameter builder we will use here, and inside this we will have to pass a unique id on every job run, okay. So write add long, and then we will use time, and to provide unique id we will use system.current time millis, okay. And after that we will use dot to parameters, to job parameters. So this will be the job parameters. Now we will have to run this job. So to run this job we will use job execution here, and we have a job launcher to run the job. So write job launcher dot run, and run method will take two parameter. First parameter would be the job name, and the second parameter would be the job parameters, okay. So just pass our job name here, and the second parameter would be job parameters. And now we will have to return string, okay. So we will have to show the status of the job. So in return we will write job status, and we will get the job status from this execution, okay. So write execution dot get status. So with the help of this we will get the job status, whether the job is completed or failed. And here in run we are getting exception, so we can handle with multiple ways. We can use try catch, but I am using throw here, throws and throwable to resolve this issue. So our controller is also created, and we have successfully created a manual endpoint to trigger our job. Now I am going to close this, and this is the s3 config file. This is our controller. This is our batch config. I have created pipelines here, and in the application.yml file here you can see access key and secret key is not provided, so I am going to paste access key and secret key here, okay. So going to pause this video, and I am going to provide access key and secret key here. So in application.yml file I have already provided access key and secret key, okay, which I got from AWS dashboard. And then in the structure you will see here multiple tables are already created, so I am going to clear all the tables first. So check all, and then I am going to drop all the tables. Delete all the tables, okay. So in the left section you can see inside this database no tables are there, okay. Now I am going to run this application to check whether it is working fine or not. So here you can see this query fired, okay, and the tables are created, and the primary id is primary key is id, and our application is running on port number 8080. Now I am going to clear all the logs, and here I am going to refresh this database to check whether all the tables created or not, okay. So multiple batch related tables created, and one more table created related to users, this table. So all tables created successfully here. Just open this users table, and here you will see 4 columns: ID, email, name, role. Okay, same columns. Now I am going to trigger our job. So this is the endpoint. Open new tab and write localhost 8080 and then write batch and then start job. So this is our endpoint. So I am going to trigger this job. Okay, so hit enter, so you can see our job is executing, and you can see all data is inserting into the database. Our batch is processing. Okay, and if you go here inside the database, my batch is working successfully. So if you refresh this table, users table, then you will be able to see all the data inserting successfully. Okay, and if you go on any of the different page number, then you will see 41,000 data inserted, and here the job status is completed. Okay, all data inserted into the database. Now 99,909 data inserted into the database.